All right, hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right back in. This is a worksheet on, I think it's called Using Statistical Models, something like that, where you have to look at data basically and then, interpret and figure out things about the data. So it's math, but it's also kind of sciencey. This is kind of something that you might see on like the science section of ACT, or you might see this under the unit problem solving and data analysis for SAT. But this is a worksheet. It's actually considered an Algebra 1 worksheet, and so we're going to jump in and look at how to answer this question. Starting with part A. Using this model, what would be the time for the fastest 41-year-old? So notice they don't actually have a time for the 41-year-old over here, but even if they did, they're saying to use the model. Using the model, which is this. So the equation is the model. Okay? Modeled by the equation, right? Not super modeled. It's just regular modeled. It's an equation. So we call that the model. Math has models too. So we plug in 41 for x because x is the age. So we'd plug in 41 for the x, and I am definitely going to do a calculator for this. So y is equal to 0.111 41 squared minus 8.1 41 plus 299. Can you guys see all that? You can. Okay. So I'm literally gonna just type this in, right? So go over here and then go 0.111 times 41 squared minus 8.1 times 41 plus 299. And I get 153.491. It says round to the nearest hundredth. So 153.491 would round to 153.49. 153.49. 153.49. Which it kind of makes sense a little bit, I guess. Kind of, sort of. It would actually make more sense, I think, to round to the nearest whole number. That way it's like an even number of minutes. Because it looks like that's how they're doing it in the chart, is they're using just rounded to the nearest whole number. But if they weren't, then it would be like minutes and seconds. You wouldn't do decimal minutes typically, it'd be minutes and seconds, which would make the answer harder. So like, I guess we can appreciate that they're not having us do, minutes and seconds. But yeah, so this is the answer for part A. Bada boom. And then let's do a different shade of blue. How about a light blue and then a dark blue for the last part? So according to the model, not the supermodel, the regular model, what would be the time for the fastest 81-year-old? So this is exactly the same thing as part A, just with a different number. So 0.111, 83. That is really old. 83-year-old running a marathon? Good for you, buddy. Let's see, minus 8.1, 83, 299. And let's see what that is. So we literally just type it in again, 0.111 times 83 squared minus 8.1 times 83 plus 299. And I get 391, nearest hundredth again, nearest hundredth, so 391.379. That would round up, so 391.38. 391.38. So 391.38. And that's it for part B. Okay. Now it says what age corresponds to a time of 171 minutes. So again, we don't really have that on the chart. It looks like 171 minutes would be somewhere between 50 and 55, right? Because that would be between, or no, it wouldn't. Just kidding. I was like, hold on. Just tripping, just checking, I was just testing you. So if we want 171, that would be between these guys. There we go. That makes more sense. And then also between these guys, or if you just look at the graph, 171 would be about right here. So yeah, should be somewhere around 50 actually. Which, I mean, 50 is 173, but you know, that's pretty close. 173 is pretty close. So, and then over here should be like whatever that is. So like, you know, young 20s. Yeah, looks about right, I guess. But how do we actually figure it out? Well, what we would do, so 171 minutes. This time it's different. Part A, they said 41-year-old. Part B, 83-year-old. They didn't say 171-year-old for one. That was like, how are you still alive if you're 171? That's my first question. And then the second question is, why are you doing anything? I mean, if they're like immortal or something, I guess it'd be like, oh, whatever. Like, I guess you would just always be, you know, have the rigor of a 20-year-old or whatever. But I don't know. But they're not 171 years old. This is 171 minutes, so that's actually a y value. So we'd plug that in here. 171.111, and now we use x because we don't know what x is. We're trying to figure out what x is. Minus 8.1x plus 299. Can you see all that? You can. Okay. So then we want to try to solve this, and we would use the quadratic formula. I think, do I have the program on this one? No, I built the program into my TI-84. I've got my TI-83 laying around over here that I've been using, but we can still plug it in pretty easily. So if you subtract 171 to get it equal to 0 first, then we can use the quadratic formula to do the rest. So 299 from 171 from 299. So that would be an 8 and a 2 and a 1. Looks right. Yeah, just wanted to double check. Okay, so I would not try to recommend factoring. That's 0.111. Yeah, no thanks. I'm not going to try to factor this normally. So A is 0.111, B is negative 8.1, and C is 128. Can you guys see that? You can, just barely. Oh, no, you can't. Okay, that's below. That's my face is in the way officially now. All right, well, I'll write over here then. So A is 0.111, B is negative 8.1, and C is 128. Right? That's A, B, and C. So quadratic formula: x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. So then we would type that in, and I'll do the plus version first. We should have two answers, right? We should have two answers. So that we should have a plus version and a minus version answer. So let's see. Negative b, so 8.1, positive 8.1 because it's negative 8.1. So negative b plus or minus, so we're going to do the plus. Negative b plus the square root of b squared, 8.1 squared. And I can leave out the negative because when you squared it's positive anyways. B squared minus 4 times a, 0.111, times c, 128. All over 2a. 2 times 0.111. 49.83. Does that look right? Yeah, that looks right, because on the graph it looks like you're basically at 50, and that's what I'm getting. And it says round to the nearest 10th this time, which, again, why are we rounding at all? Because minutes should just be minutes. If there's a decimal minute, it would make more sense to turn that into seconds. And then for age, nobody, unless you're like 5, you don't tell people that you're 5.5, right? Like, after you get to be, you know, some sort of number that's around 10 or so, you're just like, okay, I'm like, you're either 11 or you're 12. You're either 12 or you're 13. You're either 13. Like, I don't know why we're rounding at all here. So it should be 50, but if we play by the rules, then rounding our answer to the nearest 10th would get 49.8. 49.8. Yeah, because I know lots of people that tell me, I'm 49.8 years old. 49.8 years old. Yo. And then the other one would be the minus version of that. So x is equal to negative b. So 8.1 plus or minus the square root. So minus the square root of b squared minus 4 is c. 8.1 squared minus 4 times 0.111. Okay, making sure I didn't hit the 1 too many times. Kind of just button mashed it. All right, so 0.111 times c all over 2a. So 2 times 0.111. 3 ones. There we go. 23.1, if I round to 1 decimal place. 23.1 year old. Which spells yo. Yo, yo. Yeah, and that looks about right. That's about where I graphed it on the graph. And that's why using the graph is kind of helpful, because if you like stare at the graph long enough, then you'll go cross-eyed. I mean, if you stare at the graph long enough, then you'll be able to check your answer and make sure that your answer's right. So that's what we did. That's what we done. We done did. We is done. That's it. Finito. Terminaste. So, if that's helpful, awesome. Glad you liked it. And I'll catch you in the next one. And links in the description below. I have a guide called The 5 Math Mistakes Everyone Makes and How to Avoid Them. Go check that out. MyersMathematics.com. And then I also have my email down below, I believe. So if you want to reach out to me for questions, or if you want to just tell me that I look dumb, my face looks stupid, you can shoot me an email. And if you want, I do tutoring as well. So if you're looking for tutoring, you can reach out to me there as well. I believe the email's down below. If it's not, then it's mr.myers@myersmathematics.com. I will catch y'all in the next episode real soon. Blessings, y'all.